As you know, the DBA is concerned about the integrity of the database, whether it's referential integrity, entity integrity, domain integrity, etc. And one way that we can ensure integrity is through the use of the tool called transactions. And this video will step through the basics of transactions. So a transaction is an atomic unit of database work. Now, database work many times means action queries, updates, inserts, and delete queries. So sometimes we'll find we need to group those transactions together. Neither they all work or we don't want any of them to work. If only half of the transactions work, we have lost integrity of the database. Here's the options. You complete that group of statements and then you can commit it, or even if one of hundreds of them and only one fails and the integrity of the database would fail, then you roll them all back. The properties of a transaction can be remembered with the mnemonic acid. A stands for atomic. We're going to treat all of those as a single unit of work. It's consistent. So if we done correctly when before the transaction occurs, everything's consistent and we have integrity. After all the transactions occur, there's still consistency and integrity. It's isolated. Each user is given the illusion of being the only person on the system. And we'll get into the concept of concurrency control in the next video. And it's durable. So results of transactions are permanent. They are committed to the database. So a picture says 1,000 words. Let's say that we are going to have an ordering system, and this ordering system writes actually many records. It creates an update to inventory because we're going to reduce one of the products count. It's going to insert a record into sales. It's going to insert a record into order head, insert a record into order tail or order detail, and it's going to update the customer's balance. All of these must take place as a unit. Improper or incomplete transactions can have a devastating effect on database integrity. A transaction is written with procedural SQL, and it may vary from database management systems on the exact terms that are going to be used. In Transact SQL, the Microsoft SQL, we're going to use the key terms commit when everything went okay and roll back when it didn't go okay. Let's step through some action queries without transactions. They should be atomic, but they're not. In this case, before, here's our data. And we're going to add a new order to customer. Customer is actually a misnomer. This is a composite entity. Here we have our new order, which is committed. Well, whenever there's a sale, we need to do an update and total sales will go up. And now we're going to insert the order so the customer can get their product, and look what's going to happen. An error is happening. Now, this can actually happen. I just double checked and there is a table can get too large. It's up to the DBA to make sure that they increase the capacity of the table if it's getting that close to capacity that it can throw an error. In this case, the DBAs did not know that could happen, and the order did not get placed, so the customer does not receive the order. However, the salesperson is credited for the order. We're going to take a look at how to correct that error without transactions, but let's look at the basic commands first. One is begin tran, or you can say begin transaction. It identifies where this transaction is going to begin and treat the statements between the begin tran and the commit or the rollback as a unit. The commit transaction, you've successfully completed all the transactions, and they will all be written to the database, and the database will have the integrity needed. And finally, you know that something went wrong. You can issue the rollback command. Here, notice that the order is still full, but this will be the logic that happens when we treat this as an atomic transaction. This is pseudocode. So we're going to start our transaction, which is begin tran, right? And we're going to change the customer data by adding that record. And then we're going to change the salesperson's data, and we're going to try to insert into order. And we'll use an if statement. If there's no errors, let's commit, else let's roll back. Now, there was an error. So notice that the state of the database after the transaction is consistent with what it was before the transaction. So while you're coding this, the question is, how do you know there's an error if you're writing the code for it? With inserts, there is a keyword called at row count. And this is going to return the number of rows which were executed by the last statement. Of course, if you're inserting one record, you want at row count to be 1. So here we're trying to insert a record. After we've tried that, we will execute a select statement to get the row count from the previous transaction. So the row count is only set by the previous action query. Then we have this if statement. If it's not equal to 1, there must have been an error, and we can issue the rollback. For updates, deletes, and inserts, there's also a keyword called at error in Transact SQL. And to commit something, you want that error to be 0. In this example, we're trying to update a customer's credit limit. And if there is an error, let's say the error is there is a check constraint that credit limit has to be greater than $5,000, for example. Well, in this case, that would throw an error because credit limit is being assigned the value of $1,000. So if there is an error, this will be not 0, and that is the symbol for not equal to 0, and we will roll back the transaction. Notice there's also a keyword we can use in Transact SQL that will send the error message back to whoever's executing this transaction. Finally, if you've done any coding in Java, C#, Python, JavaScript, many other languages, you will know of try-catch clauses, and we can use that with transactions too. So try means I'm going to try this block of action statements. And catch means, whoops, there's an error and I caught your error. So the keywords are begin try and end try. In between this, right before the end try, you know everything worked. If you're still there, what's going to happen when you use the try catch block is if there is an error, it jumps straight to catch. And when you get right to the end try, then you know you can commit. And then the catch block comes after that, and you know when you're in the catch block, something happened and you're going to roll back. In this example, we're using a begin try, and we're going to try to, first of all, insert into invoices. Then we also need to insert into line items. And there's a second record we're inserting into line items. All 3 of these inserts must work. If we get here, they did work, and we can commit. Notice right before the end try. If one of these fails, it will automatically jump where it failed into the catch block. And in the catch block, I have a rollback tran. So none of these will be updated. The author introduces a transaction log, and a transaction can use that transaction log to maintain a list of what's going to happen if we commit or if we roll back. If you look in the textbook at table 10.1, there's a sample transaction log. Here we are at this table, and this transaction log has an ID, which is just an auto number. It also has a transaction number, and so all of these statements are related to one transaction. They're all transaction 101. And it just has a pointer. This is the beginning of the transaction, the next statement, and just has a pointer to the next statement. This is the first statement, begins with null. The last statement ends with null. And then what's going on. And so there's a start, 2 updates, and a commit. So this transaction successfully committed. So the updates will have a list of the table, the row ID, that would be the primary key, the field or attribute being updated, the value before update, and the value after update. If you recall, the video last week talked about audit logs, and this is a little different than an audit log. The transaction log, of course, objective is not to find out who modified records, but to make sure that the integrity of the database is maintained through storing transactions as an atomic unit